Cool. We are going to talk about open source pure Python data stacks today. I'm really super excited to see so many people here, despite my talk not having AI in the title. It feels like that was the way to get the most number of people to come. This is me. I've got a friendly hand-waving emoji. I'm head of engineering at Tasman Analytics. We're a boutique data and AI consultancy. I did manage to sneak AI in there, but it's on the second slide. And we help our clients turn disorganized data into insights. That's what we do. We've got a base in the UK and the Netherlands, but we work internationally. That's us. We're a friendly bunch. There's about 20 of us, and yeah, we love data. So if you've got any data questions, come and find me later. Who is this talk for? I tried to and distill who might get benefit out of this talk, and the best I could do was anyone who's interested in building a data platform. I'm hoping that by the end of this talk, you'll sort of learn some of the fundamental components of a data platform or a data stack. It'll help you make some sensible tooling choices, and you'll also learn from our experience, because we do this for essentially every client. We set up a data stack, and so we've had a lot of experience with lots of the tools available out there. I also thought I'd put this little statistic in from the Stack Overflow developer survey. About 50% of developers work in companies that are smaller than 100 employees. So that means that as a developer, as an engineer, you're probably called to wear many hats. And if this talk can help you set up a first data stack for your company or for a side project, then yeah, I'll be very happy. I also like to get some caveats in very early. So this is really the art of the possible. I'm not saying this is the only way to choose the technology. I'm not saying that these are the only tools or they're the best tools. These are currently my favorites, and my list of favorites evolves all the time. The stack that we'll sort of develop and talk through is capable of handling gigabytes, maybe even tens of gigabytes of scale. But it is dealing with batch processing. If you're interested in stream processing, you can swap up some of the components, and all of the fundamentals will still apply. And then lastly, if this is something that you're doing for your company, as with any engineering project, consider the benefits of buy versus build. That is, what technology might you sort of hive off to a managed service, and what are you going to build yourself? All right. So with all of that disclaimer out of the way, let's talk about data stack. What is a data stack? So this is all of the fundamental components in a nice Excel drawer. Of course, you need some data sources. So this could be REST APIs, could be flat files, could be SaaS tools that you're integrating with. The idea is that your data stack is going to draw in data from different sources and help you make use of them. Pipelines are the thing, or the component that helps you bring data from those sources into your data store. Your data store is simply a repository where all of your data lives. It could be a data warehouse, it could be a data lake, it could even be flat files. Transformation is the process of taking that raw data you've extracted from your source systems and turning that into actionable insights. So here, there's this concept of layers where you're taking the rawest data from that first layer all the way through to a curated layer where you've done some transformation and made that data valuable. And finally, the orchestration engine is the thing that sits around all of this. It coordinates the flow of data from pipelines into the data store, the transformation of data from raw to presentation or curated layer, and it gives you insight into the state of your data stack. And finally, you've got this great layer of highly trusted data. To make use of it or to enable anyone to really sort of understand what that data is, you want to expose that through a visualization layer. All right, when to build? So it's likely that you've started off with some ad hoc analysis, maybe a pandas notebook, maybe something, maybe something written in pure Python. Or you may be, and you want to move it to the next step. You may also start wanting to combine data from different sources, which often can be difficult in a local environment. This is the biggest kind of benefit, which is that other people are interested in your data, and so you want to have a more production-ready data stack. Data volumes increase exponentially every year, and as soon as you hit a certain threshold, it becomes more and more difficult to process that all on your machine. And finally, you want to bring some robustness and trust into your data. So let's build a stack. I thought to make this less dry, I would rely on the Star Wars canon. And so the sources that we're going to pull from are a Star Wars API, some flat file that has data from Rotten Tomatoes and Wikipedia. For the pipeline element, we'll use DLT. For the data store, we'll run it locally, so it's DuckDB. Orchestration is handled by Dagster, and visualization by Streamlit. I was disappointed that Streamlit is the only thing there that doesn't start with the letter D. So in my mind, I referred to it as Dreamlit. Setting up the repo, important to follow good software engineering practices, so separation of concerns. Each of those modules represents each component in the data stack. So we've got the orchestration module, the transformation module, visualization module. I've whacked the database in there as well because this is a local project. And finally, telemetry to capture all of your logs and state files. All right, let's get into it. Pipelines. So as you recall, pipelines move data from source to data store. There are loads of tools out there that do this work. Airbyte, Meltano. You could even write it in pure Python using something like requests. But for the purposes of this exercise, we're going to use DLT. And just recovering again the sort of source of data that we're pulling from: Star Wars API, Rotten Tomatoes, Wikipedia. Right, let's start with the Star Wars API. This is a public API accessible for anyone who wants to go and have a play around with this. It provides different endpoints for different let's say, properties or attributes of the Star Wars world. So we've got films, people, species, and starships, all of the important things from the Star Wars world. The file source, for the purposes of this exercise, is just local on my machine, but actually it represents a very common use case, pulling files from a cloud bucket or some other sort of cloud-based storage. And this file just contains, some financial information, so budget of the films, box office takings, and also the ratings given by Rotten Tomatoes. Right, DLT. So for each of these components, what I've done is I've copied the sort of tagline from the website, and we'll see if actually the real world use case or implementation of the pipeline matches what they're saying the tool can do. So DLT claims it's a lightweight Python code to move data. I like it because it uses a declarative paradigm, and it's also very flexible and simple syntax. So the screen grab shows what's on their website, that you can get data from a REST API just through a few lines of code. Now, does the reality match the marketing claim? So this is actually the configuration to get the data from that REST API. You can see the base URL. You can also see all of the endpoints of the films, starships have been highlighted. You've got planets and species there as well. So, that's a fairly terse syntax, and that will pull you all of the data that the REST API has. I haven't implemented any limits because YOLO, but you can implement limits as well. An important part of accessing any API is how you deal with pagination. So this is the case where the results are too big to fit into a single response. This API has some endpoints which just provide all of the data in a single page. So for example, films, there are only 9 films at the moment, so that all fits into a single page. But then, for example, starships, planets, species, there's more data than could fit into a single page response, so you need to page through those responses. Here, DLT gives some really useful classes that automate this. So using the JSON link paginator, it basically follows the link in the URL that's provided by the response and just iterates through those URLs until it exhausts all of the pages. No like while loops, for loops to do that manually. It handles all of that under the hood. When you're pulling data from an external source, you guarantee that it will change at some point. Schema changes are handled quite easily and tersely as well. So there's 3 entities that you can manage or control how they sort of deal with the change in schema. You can control it at a table level, so specify whether a table should be created if, let's say, some new data is provided, whether columns can be created, and then finally, whether a data type of an existing column can be updated. For each of those entities, you've got 4 contract modes. Evolve just means that the schema of the tables that receive the data is always changing. So if a change happens at the API level, that's mirrored in your data store. Freeze means that an exception is raised as soon as a change is detected, while discard rows, discard values mean any changes to what already exists in the data store is discarded in some way. Either the whole row is discarded or just a particular value in the column that is different to what's in the data warehouse. All of this basically means you can control how changes materialize, how changes are handled in your code. And for sure, it's going to break something. This allows you to control what breaks and how you deal with the new schema. I'll just touch quickly on authentication. Helpfully, the Star Wars API is completely unauthenticated, so it didn't need to use any of this. But it again exists. This is for the Guardian newspaper. That they have an API key, and again, very, very simple implementation of that. File sources. So this is, remember that there was another file that we were going to bring in as a source, and unfortunately my little square has failed me. But what you can see is the syntax is exactly the same for a local file system as would be for a cloud bucket, GCP, S3 bucket, or Azure Blob Storage. Yeah, again, very, very simple and terse. So I think, as far as I'm concerned, it does live up to the hype. It is a very simple library to use. It's very flexible syntax, and it's super easy to extend. You can, sort of subclass any of those base classes and create your own implementation of pagination, authentication, etc. Right, data stores. This is where all the data lives. For the purpose of this demo, I haven't bothered using a cloud data store, which is what I'd usually recommend for a client. Loads of very good technology out there at the moment. Snowflake, who are here, Databricks, BigQuery. Iceberg is new and gaining quite a lot of popularity, and then MotherDuck is the sort of the managed service version of DuckDB. It is an important decision, but often it's just, it's not one that I would spend too much thinking on, because all of them provide a very good feature set and likely suitable for your use cases. DuckDB is a in-memory OLAP engine. Just hands up if anyone's used DuckDB here already. Cool. Yeah, it's one of our favorite technologies now because it's just so fast and so portable. Perfect for small to medium data sets. It can go up to tens of gigabytes very easily, but it can also do sort of processing of out-of-memory volumes of data. Something that I used quite a bit for doing this this sort of demo was the new notebook UI. It's super simple. It's not as sort of feature packed as Jupyter notebooks, but for the purpose of exploring data and doing some like really simple, quick explorations or ad hoc analysis, it's really great. And here I've just highlighted the sort of tables that DLT has created. So it not only has it created the source tables from the API, so you can see the films, the people, plants, species, but it's also created the metadata and state tables as well automatically. Yeah, that's it. All right, transformation. This is the secret sauce. This is what turns that raw data into really valuable, like a valuable asset. It's an opportunity for you to centralize and sort of agree business modeling logic with stakeholders, the rest of your company, other people you might be working with. And using the right tool means that you can increase the accessibility of this so that it's not just you who knows how that particular metric is calculated. Anyone who can read the code can also understand that. And really, you want to sort of centralize this because it can then become the single source of truth along with the data. Loads of libraries exist, Python open source libraries. In the SQL world, there's DBT and SQL Mesh. In the Python world, there's pandas and polars, Dask, PySpark, and all of them are mature libraries that you can use without having much doubt. I want to go back to this idea of processing layers. So we follow a sort of medallion architecture, but we've renamed each of the medals. So the idea here is that you're processing data and taking it from a very raw format into a curated format. So the raw is just a landing zone. Staging is where we generally clean up the data. So fixed case, change columns to more sensible naming, etc. The domain layer is where we then model that data and create core entities. So sort of domain modeling as you would do it in software engineering, and data modeling as well. And finally, we've got the curated data layer, which is the sort of the gold standard. This is the trusted layer, and this is the layer that you would then expose to your stakeholders, your clients. The idea is that you've implemented really sort of robust data quality checks and modeling so that no one has any doubts about the sort of validity or the accurateness or the trustworthiness of the data in that last layer. DBT is probably the incumbent transformation engine. It's a library that we've used a lot and still is the one that we would default to, although we're trying out SQL Mesh at the moment. It gives some really great features to maintain data quality by testing, documentation, and providing table-level data lineage. It also has some great sort of DevOps features, CI/CD, version control, etc. And the game changer really is how it materializes these tables. So it uses data models to establish the SQL transformation, but then you can choose whether that's materialized as a table, whether it's materialized as a view, whether it's materialized as, let's say, an incremental model, so you're only processing the latest data. And it gives loads of flexibility in how you structure your transformation engine. This is the lineage graph that DBT provides as part of its DBT docs feature. And so here you can see that concept of raw staging domain presentation mirrored in the actual lineage. So here we've got the raw data that is brought in by DLT, staging tables, domain, and of course the domain has the sort of key entities in Star Wars canon. So entities that I'm very passionate about: starships, species, planets, finances, because we want to know if there are going to be more Star Wars films, and characters, of course. And all of that flows into a final sort of presentation layer, which are two tables. One that gives us information about the attributes of the film, and the other gives us information about the sort of the films themselves. Here I just wanted to quickly touch on lineage. DBT provides a nice way of showing the relationships between different models. And so here I've selected the presentation film model, and you can see it track all the way back to the source tables. I'll quickly go through this. This is how you set up a model. It is a little bit of a, it has a config block at the top. It then sets up the relationships from the source tables, and finally it has the actual transformation logic in SQL. And so you can see here the domain film finances is selecting from stage films metadata and stage films, and then the presentation films is selecting from the domain film finances. This is a slightly contrived example, and so the transformation is very light, but you can do very complex transformations using DBT. Anything you can do in SQL, you can do in DBT. A really great feature of DBT is the test, the native test that it provides. So tests help you validate that the data conforms to your expectations when you're designing the models right at the start. But then they are run every single time, or you can choose to run them every single time that DBT runs. So it means that every transformation that happens, you can run a full suite of tests after it, and so maintain data quality in flight. So you're not caught by error values coming in and being served out to your clients. The tests will break, or you can set them to warn, depending on the severity of the test. And it can test things, out of the box, very, very simple things like whether values are unique, whether there are any nulls in a particular column. It can also do, a whole lot of tests that I've listed there. Special shout out to a library called DBT Expectations, which gives you even more tests, and including like outlier tests and whether your volumes of data are changing by, dropping or increasing by a huge amount. So you can then be very, very, you can trust that, when your DBT transformation runs, that it is constantly serving up that, constantly keeping up that quality of the data by running these tests afterwards. Cool. Orchestration, we'll just take a drink. Again, with orchestration, there are loads of tools out there. Probably the most popular ones are Airflow, Prefect, and Dagster. Dagster I really like because it is, again, it uses a slightly different paradigm to all the other tools. It's focused on assets. And what Dagster defines an asset to be is the persistence of data in a particular location. So it could be a database, it could be a data warehouse, it could be a file. And the configuration of an asset defines how it should be materialized, where it's saved, and then how it should be updated. And so Dagster, rather than worry about the flowing of data, the processing of data, it's more concerned about, or it is concerned about, how that data, where that data is materialized, and what that data is after it gets to its endpoint. A good orchestration tool should give you this single pane view of not only your pipelines, but also your transformation engine. So here you can see the, I don't know if you can see my mouse, yeah. So here you can see a group that has all of your API ingestion endpoints. You've got another group here for your file ingestion, and then you've got your different layers in DBT, staging, domain, presentation. If you expand, for example, the API ingestion, you can see each of the endpoints documented. Each of the endpoints are documented, and if you click, one of those assets, it gives you a whole lot of metadata configuration as well. It even shows you the schema of the table in the data warehouse, and this is really, really useful when. And I say when your pipelines break because they always break. This helps debugging, and it can save you hours because you can see the view of not only the pipelines, but also what's happening in the DBT project as well. There is really tight integration between Dagster and DLT and Dagster and DBT. And so it uses all of the configuration that I showed previously for your REST API source, but it brings that into a Dagster syntax by using this DLT assets decorator. And so here, it's Veritas syntax. Most of that code is a decorator, and then you get to the function definition, and all it is it's yielding the results from the pipeline run. Then this is the that was the file source. Sorry, this is the API source. So again, very similar syntax, but then and again it just yields the output of the pipeline run. And so you can see, the things that you're providing are really just the name of the dataset, the schema, name of the table. You're calling the Star Wars API source, which was the configuration that had the REST API source configured, and then the destination as well, which is DuckDB. So that's pipelines. Let's move to DBT. Here, there's really tight integration, so you can see all of those models that you saw in DBT in the data lineage graph are mirrored here as well, and so you can still get all of that nice data lineage coming through into your orchestration platform. This doesn't happen with all of the orchestrators, and it's one of the reasons I really like Dagster. And again, here, if you click into any of those models or those models, you will get some nice data that'll help you troubleshoot issues. So you get the actual model definition, but then also execution time as well. So you can see if it's taking longer and longer to run that particular model, or if it's fairly stable. And again, here, specifying a DBT asset is done in a very similar format: decorator, and then yielding the actual run context. Now, how do you join DBT to DLT? This took a little bit of working, and really, all you need to do is specify the name of the asset key from that Dagster gives to your DLT asset in your DBT project. So this is the sources.yaml file where you establish or you declare the sources that are coming into your DBT project. And by passing this extra bit of configuration, it allows Dagster to join up your landing table with the actual pipeline asset. And finally, bring it all together, definitions. So assets in Dagster are combined into a definition, and a definition works out what is the order to run assets. So what is the relationship between assets, and how should those be executed to then generate those assets. A job here is essentially like a DAG. It is a select grouping of those assets, and so you could have multiple jobs in an orchestration. Okay, finally, visualization. The last bit of the stack. This is the point where you've done all of this work, you've got trustworthy data, and you want to show someone that data. As engineers, we all love looking at numbers, looking at columns, looking at tables, looking at data frames. Non-technical people hate looking at that stuff, so you need to have a visualization layer. Over time, we've become bigger and bigger fans of Streamlit just because of the sort of speed of implementation. It's written in pure Python. If you choose Snowflake as your data warehouse, Streamlit is built directly into it, but you can also host your apps on the Streamlit cloud service. And you can build both AI and data apps, and even simple web apps as well, really. So it's really easy to get a prototype out to your stakeholders. Very simple, I have to say, a faster way to build and share data apps. That was the marketing tagline. Here's how you set up a heading in your app, this will probably be a little bit meaningless until I show you what it looks like. But your sort of title of the app, how you create a sidebar so you can have some links in there. And then this is the sort of function to pull data from your database into the Streamlit app. I've used this cache data decorator because by default, Streamlit reloads all of the data on every single event. And with small data sets, not a problem, but with large data sets, it can lead to really slow response times. Another thing probably of note here is that I'm using pandas just for a little bit of variability. Yeah, it's nice to flex those muscles from time to time. So yeah, the df equals con.execute query returns a data frame, a pandas data frame, if you use that fetch df method. And finally, the code here looks more complicated than it is. It generates this chart on the right. But actually, most of it is just about setting access labels, setting your scale, etc. There is like a really simple Streamlit chart method that you can use, but it doesn't give you enough configurability, or didn't give me enough configurability. So I've gone this slightly more complicated route using Altair, which is included in Streamlit. Right. That's all the Stack stuff. We haven't really talked much about Star Wars. So, if you excuse... Oh, uh-oh. Sorry. That was weird. Okay, let's do this. And can we go full screen? Okay, maybe I'll just zoom in a little bit. Okay, so this is a Streamlit app just running locally. It's connected to the DuckDB instance. And let's talk about Star Wars data. So as you can see here, budgets have been expanding quite significantly over time. It looks like we have, it starts from about 11 million for A New Hope. It goes up to about 45 million in the original sequels. The prequels jump that up to 100 million. And then there's another step change in the sequels as well, where the budgets are 4 times that, so about 400 million each. How does that reflect on box office earnings? So A New Hope, the original trilogy obviously earned significant amounts at that time, but sort of pale into insignificance compared to the prequels and the more recent sequels. So A New Hope earned 775, let's say 800 million, whereas Phantom Menace was $1 billion, and The Force Awakens 2 billion. So significant returns of money on that original investment. And also an interesting thing, well, to me, was that each of the first films of each trilogy earned more than all the subsequent films. So it feels like people were really, really keen to see those first films and then maybe slightly disappointed, and so didn't go back for films 2 and 3. Now, what was the return on investment? A New Hope was 11 million budget, but returned 700 million. So that's a 70x return on that original investment. But it looks like every film afterwards has not lived up to that hype, despite the ever-expanding budgets. So interesting little bit of knowledge there, in case you want to share that with your friends at your next dinner party. And last thing I'm going to leave you with is, has the increasing budget given us a more diverse, more exciting Star Wars universe with more characters, more planets, more species, and more starships? Unfortunately not. It seems like A New Hope gave us the biggest bang for buck. Small budget, but with lots of different species, planets, characters, and starships. And everyone else, all of the other films since have sort of been much lower. And with that, I think we'll draw it to a close. Thank you for your time.
All right. Thank you, Eric. That was really comprehensive. There is also a lot of questions on the Slido. I'm just going to start off. So, why would you recommend dbt over SQL Mesh? Or what would be reasons to use SQL Mesh?
SQL Mesh is exciting because it's new, and dbt has been around since, I think, about 2017. So there is the novelty factor, but actually SQL Mesh has a few features which are really nice. So it has this idea of sort of like blue-green deployments where every run happens in a new schema, and then you swap out the schemas. So it means that if there is, let's say, some bad data that creeps into your most recent run, you can roll back very, very easily. It also, which I think helps a lot with really large data sets. There's also the actual native IDE in SQL Mesh is really nice as well. So yeah, some quality of life improvements.
All right, thank you. Given that Dagster also models data lineage through so-called data assets and provides validation features, why do we still need dbt as well?
Sorry, could you just repeat that again?
Right. Given that Dagster also models data lineage through so-called data assets and provides validation features, why do we still need dbt as well?
Yeah, okay, fair. Dagster just does that. So dbt gives you all of the additional benefits of better source. Like it has inbuilt version controlling. It has useful CI/CD helpers. It has the testing. I think for me is probably the biggest benefit. You can set all of that up in Dagster, but dbt just makes it super simple. You just have to configure some YAML, and you get as many tests as you need.
Right. For Python, there's PyTest. How can I verify that my dbt SQL is doing what I expect it to do?
You can write unit tests in dbt, but it's quite painful. So you definitely can. I would use a combination of unit tests to test the most important models or the most important transformations, and then rely on those schema tests for actually testing the values.
All right. Do you have an opinion on data business catalogs like DataHub? And how do you connect your data stack to it?
Yes, I do. They are very useful for expanding knowledge of your data and surfacing that knowledge wider around your business. But implementation is never the problem, adoption is. And so whether or not you can actually get people to look at it should be the driver to launch that project. But we've certainly helped clients do that. But then it's a much bigger task to then make sure people in the business are comfortable enough and practiced enough so that they refer back to that data catalog over just slacking someone.
All right. dbt and Dagster have a cloud version and an OP version. Do you see any features that were introduced in the cloud version and never made it to the OP version?
Well, there's the AI feature. The dbt cloud version actually is a really good product, and we would recommend it. Maybe for clients who don't have a very big technical team, or they don't have sort of specialist data people, then dbt cloud makes it super simple to get all of those benefits. The caveat is that it is getting more and more expensive, and so again, it comes back to that buy versus build debate.
All right. When the data size grows into hundreds of gigabytes and more, what changes would you make to your pipeline?
Hundreds of yeah. So processing data incrementally, that is the first step, really. As soon as your data is taking a long time to process, it means you are chewing up compute, and you're also using up a lot of compute of your pipelines, but also compute of your data warehouse. And so being able to move to an incremental model where you're just processing the most recently arrived data, and really helps, and that solves a lot of problems. And then then you can deal with sort of the next level up, the next size up with more sort of with a different set of tools. So maybe you may need to look at a data lake versus a data warehouse. Yeah.
All right. Well, that's it. Thanks again for all the questions. Thanks to Eric for the amazing talk. If your